Hello, my name is Luis Juarez and I'm going to explain the different rules for derivatives. First, we're going to start with the product rule. The product rule, as we can see, follows this formula, which means that if we have one function here, it will be the derivative of that function multiplied by the non-derivative of the second function plus the non-derivative of the first function times the derivative of the second function. Here's some examples to make it more clear. Here we have x cubic times x squared plus 2x plus 1. This will mean that the derivative of x cubed is equal to 3x squared that multiplies this, that is the non-derivative of the second one, plus the non-derivative of x cubic, which stays the same, times the derivative of the second one. When we solve, we get 3x4 plus 6x cubic plus 3x squared plus 2x4 plus 2x cubic. And if we want to express it in a more simplified way, we get this result, which is 5x4 plus 8x cubic plus 3x squared. So basically, the product rule means that when we have two functions, we're going to have to get the derivative of the first one and multiply it by the non-derivative of the second one plus the non-derivative of the first one times the derivative of the second one. We just have to be careful by looking at which ones we have to find the derivative and which one has to stay the same. Here is another example. We have sine of x multiplying 4x plus 1. We want to get the derivative first of sine of x, which is going to be cosine of x, times the non-derivative, so we pass this as it is, 4x plus 1, plus the non-derivative, so sine x goes here, times the derivative of the second one, which would be 4. For the last example, we're going to use e to the x times 5x squared. When multiply this, we're going to get the derivative of the first one, which remains the same, times the non-derivative, so we get again, this stays the same, plus the non-derivative, which is e to the x, times the derivative of 5x squared, which would be 10x. Then, when solving this, we'll get ex 5x squared plus ex 10x. And this will be our final result. The second rule I'm going to explain is the quotient rule. As in the product rule, we have a formula, which is the derivative of the first one times the non-derivative of the denominator minus the non-derivative of the numerator times the derivative of the denominator. So basically, here we have the same formula as in the product rule, except that we change the sign. And we have to get the denominator to the square. So we have the denominator to square as our denominator for this formula. Here's an example. If we get x plus 1 by x, we're going to have the derivative of the first one is going to be 1, as it's only x, times the non-derivative, which is in this case x, minus the non-derivative, which is x plus 1, times the derivative of the denominator, which is again x, by the square of the denominator. So we're going to have, by multiplying and simplifying, we get x minus 1 by x squared. And as a result, we have this cancel each other, and we have minus 1 by x squared. As a second example, we have pi minus 1 by e to the x. Pi is a constant, so our derivative is going to be 0. So we have the derivative of the first one, which in total is 0, as two constants is equal to 0, times the non-derivative of the denominator, which stays the same in this case because it's e to the x, minus the non-derivative of the first one, which would be pi minus 1, times the derivative of the second one, which stays the same again. All divided by the square of the denominator, which would be e to the x squared. And now, when we simplify, we're gonna get that this cancels out as 0, and this we can express it like pi minus 1 times e to the x by e to the x squared. And this would be our final result. We have to remember that e to the x would be the same derivative as the non-derivative because of this case. And that pi is a constant, is a number, so the derivative is going to be 0. And for our last example, we have sine of x plus x by x squared. This we're going to have to get the derivative of the first one, which would be cosine of x plus 1, multiplying the non-derivative of the denominator, which would be x squared, minus the non-derivative of the first one, which would be sine x plus x, multiplying by the derivative of the denominator, which would be 2x. All of these divided by x squared to the square, which would be x4. And our final result would be x squared cosine of x plus x squared minus 2x sine of x minus 2x squared, all divided by x to the 4. And the last rule of derivatives that I'm going to explain is a chain rule, which follows this formula, f of u times x, which means that we have to solve it like this. Derivative of f times u multiplied by derivative of u times x. It may sound complicated, but it's pretty simple. Here's an example that makes it look a little bit simpler than it is. We have to first define what our u is and our f. In this case, we have that u is the function inside the parentheses and f is going to be the square. We get the u and get the derivative for that, which is 2x. And then we get f, which would mean that f is equal to u to the square. Get the derivative for u squared, which is 2u, and then multiply. So the derivative that we got from u times 2u, which would mean that we get this one, we make it inside the u, and multiply by 2, and then that we get to multiply by 2x. We get this as a result, and when simplifying it, our final result would be 4x cubic plus 12x. And for our second example, we're going to have cosine of 2x plus pi. We again first define our u and our f. Here again, u is our value inside the parentheses. So we get u equals 2x plus pi. We get the derivative for this, and it would be 2, and then f would be cosine of u, which is this. We get this derivative would be minus sine of u, and then we only have to multiply. Here we multiply the 2 times this one, which would be 2 minus 2 sine of u. We take our u inside the parentheses of sine, which would be 2x plus pi. And this would be our final result for this function. For this third example, we have sine squared of L logarithm, natural logarithm of 2x squared plus pi. Here we have to make it by steps. First, we're gonna do our first step, which is this would be our u and this would be our f. We get the derivative for our u, which is 2x squared plus pi, equals 4x. And that would be it, because again, pi is a constant, and here we get to the exponent multiplies the coefficient and gets a minus 1. That's why it's 4x. And our f would be natural logarithm of u, which is equal to 1u, because as we know, the derivative for natural logarithm would be 1 over x. And here multiplying it, it will take the place of u. Then, when solving, we have to multiply again. This multiplies the 1 of the fraction and would be 4x by our u, which would be 2x squared plus pi. here's our first step for this function. For our second step, we're gonna have to define again f and u. Here we had these ones, but now we have to get first the sine square. For this, u would be our sine and f would be our square. We get that u equals sine, which is equal derivative to cos, and f would be u squared, which the derivative is 2u. We multiply again and we'll get 2 sine cosine. This is our second step, and now we get our third step. We define again f and u. Here we're gonna have that our u is this one, and our f would be sine squared. Then we solve. U, we already know the derivative of natural logarithm of 2x squared plus pi, which you got on the first step. So this one is the derivative. And f, which means that this one is our derivative. However, we're gonna have to get 2 sine of u cosine of u, so that we can get these ones inside the parentheses. We're gonna have to multiply again this derivative times all of this, which would mean 4 times 2 is 8 x sine of u, which would mean that we get this one inside the parentheses, cosine of again this one inside the other parentheses, all by 2x squared plus pi. And this would be our final result. As a conclusion, we can say that we have 3 different rules: product rule, quotient rule, and chain rule. However, we can find them all mixed on a function. For that, we have to be very careful and solve by steps one by one, applying all the different formulas. You by now should know already how to apply these 3 rules. And if you don't, I don't know how did you pass the exam.